Today's video is about plate tectonics. As we have studied before, the Earth is made up of layers. The outer rocky layer solidified billions of years ago, right after the Earth formed. This crust is not a solid shell. It's broken into plates that we have talked about before. But just to review, we have the rocky crust, the outer mantle, the inner mantle, and the edges of the plate. The crust is the outermost layer, and we know that it's 5 to 100 kilometers thick, and it's mainly of oxygen and silicon. So we have oceanic crust here, and we have continental crust. Then we have something called the mohorific discontinuity, otherwise known as the moho. Then we have the upper mantle, which is rigid, and that's all part of the lithosphere. Then we have the asthenosphere, which is like a softer rock, and then the lower mantle, which is rigid. The mantle is a layer of the Earth between the crust and the core. Most of the Earth's mass is actually in the mantle. Has magnesium, not as much aluminum and silicon as the crust, and it's not as dense as the crust. Then we have the core, and below the mantle and to the center of the Earth is where the core is. We think it's mostly iron and nickel, no oxygen really, no silicon, aluminum, or magnesium. We also know that the Earth is broken up into tectonic plates. There are 7 major plates on Earth. The name comes from Tectonicos, of a builder. They're the pieces of the lithosphere. Remember, that's the upper part of the mantle and the crust that move around. Each plate has a name. They fit together like jigsaw puzzles. And they float similar to ice cubes in a bowl of water because it's less dense. The continental drift, which we have looked at before, and we've looked at this very specific video in the past. Alfred Wegener in the 1900s, they thought that continents were a single landmass that drifted apart. We know that there are fossils of the same plants and animals found on different continents. This supercontinent was called Pangaea, and when it split into Laurasia and Gondwana about 180 million years ago. But as we know, we're not sitting still, that there's still continental drift. There's evidence of Pangaea. There's fossil records that show us that parts of different continents had to be near each other and had to be in different parts of the planet. For instance, Antarctica has ferns, and ferns don't grow in Antarctica today, which means it had to be a warmer climate at that time. But you can see here some of the different fossil evidence that shows us how the continents were put together. Now this is something new for us. This is seafloor spreading. And what is happening is the plates are moving apart from each other along the seafloors, and that is what's pushing the plates. There's, under the oceans, we have something called mid-oceanic ridges, and they are underwater mountain chains, and they go through the bottoms of the ocean. And magma rises to the surface and pushes the plates apart. The older crust is pushed farther away from the ridges. Plates move as a result of convection currents, which is something we will be looking at in another video and working with in class. There's different types of boundaries. We have transform boundaries, we have divergent boundaries, we have convergent boundaries, and based on how the plates are moving, it's how we name the boundary. A divergent boundary is where 2 plates are pushing apart. So we know that the Arabian and African plates are pushing away from one another. Another divergent plate is Iceland. The North American plate and the Eurasian plate are pushing away from each other. This is an oceanic divergent boundary, and as the plates push apart, mantle comes up it solidifies, and then it pushes out again. So you can see in this drawing. So it pushes open, then the mantle comes up, it's melted, it pushes, it begins to solidify, and then it begins again. So a continental divergent boundary is similar. What happens is the continents push apart and they may fill in with water. So you can just see how that works here. Some convergent boundaries would be like the Indian Eurasian plate. That's where two boundaries are pushing together, and you can see that there's a mountain range forming there, and that is where two plates meet, and then the Earth begins to move upward. Now we have convergent boundaries where an oceanic plate is meeting a continental plate. Because the oceanic plate is so much thicker and denser, it will actually slide beneath the continental plate and go back into the mantle. If we have an oceanic plate, we will still have one of the plates go down below the other plate, and it will go into the mantle and become melted again. Where we have continental convergent plates, we can see that we get mountain ranges. We have continental crusts pushing into each other and pushing up, and part of the crust will go back down, but we get a lot of upward movement as well. Now, a transform boundary is when two plates are sliding one past the other. We have this specific type of plate with the North American plate and the Pacific plate, and that is what causes the earthquakes that occur on the West Coast. One plate is moving north, one plate is moving south. So please answer these questions in your notes, and this is what I will be looking at to make sure that you got the information from this video.